Hello guys, and welcome back to another video. So today we're going to be making glyoxime and nitroglyoxime, and yeah, let's get started. Also, I want to give a special thank you to my $10+ patrons for their huge donation, so thank you very much. So to even begin, I actually have to make the glyoxime, so it's really not that hard. All I need is glyoxal that comes as a 40% solution off Amazon. I also need potassium hydroxide, which I got off of Amazon, and hydroxylamine hydrochloride, which again I got off Amazon. So to begin, I simply just dissolve potassium hydroxide into water. You can also replace this with sodium hydroxide, but whatever, and then I throw it in an ice bath and cool it down to 0 Celsius. I then take my hydroxylamine hydrochloride and freebase it, which I do by putting it slowly into this basic solution. After I add all the hydroxylamine hydrochloride, I let it stir for a little to complete the reaction, and in the meantime, I make a second solution of glyoxal and water, which is what I'm making right here. Now that everything's actually ready, we can start additions. The additions take a while because I have to add over 100 milliliters of this solution, and it just takes so long because you have to keep the temperature under 10 degrees Celsius. Near the end of the additions, the solution goes from cloudy to a clear yellow color. Hopefully it means that it worked. So here's what it looks like after about a minute of finishing adding everything, and the glyoxime is actually crashing out already. So now I'm going to let it stir for around an hour to make sure that my reaction is finished. So here is what the filtered product looks like, and essentially what we're now going to do is recrystallize it in boiling water. And the solubility curve of this is very, very cool because it's not very soluble until you get to around 80 Celsius, which it just all suddenly dissolves. This is what the crystals looked like, and I kind of failed the reaction, so I had to redo it. And here are the secondary batch, which is much nicer. So of course I'm now going to do a burn test. That was a really clean burn, so it must be very pure. Okay, so now I'm going to make nitroglyoxime to compare what it's like. In order to make nitroglyoxime, I'm going to need diethyl ether and nitrogen dioxide. The diethyl ether that I'm going to be using is going to be distilled from starting fluid. But there's a slight issue. When I plug it in, yeah, you hear that? That's not good. Alright, I'm going to have to figure that out. Okay, it's almost about to work. Look at that. No way. So I finally managed to work with the pump, and it ended up distilling over around 80 milliliters of ether, and I'm trying it over magnesium sulfate. So now I'm just going to dissolve the glyoxime into the ether, and I was going to originally do the reaction in this vessel right here, but I decided to transfer it to a graduated cylinder because that was going to be much easier to bubble the nitrogen dioxide through it. Now there are a lot of methods to making nitrogen dioxide, however my favorite one is a fellow YouTuber making it, and I'll show you the video. Glycerin? This is awful. Alright, that's enough. So obviously I'm not going to make my nitrogen dioxide that way because that method's a little unstable. So I'm actually going to make it by just dissolving copper in nitric acid. Okay, so here is my crude setup. So here I have the diethyl ether solution of glyoxal, only about 1.5 grams, looks like it dissolved, so I have about 1.5 grams in there. Now what I'm going to do is I set up a nitrogen dioxide generator, which is nitric acid, and I'm going to drip it onto here, and it'll produce nitrogen dioxide, which will then drip into there, or dribble into there. So after this nitric acid is used up, that'll be the end of the reaction. So let's start it. So here I have a time lapse of the nitrogen dioxide being bubbled through, and as you can see, it starts off being pretty colorless, which is the air flushing out through the system. And then once the nitrogen dioxide really comes through, you can see that a reaction starts to take place, as you can see with the vigorous bubbling. I know that the reaction's done when I run out of nitric acid and the bubbling is a little less vigorous. So as you can see, there's a lot of NO2 being outgassed now, and none of it's really reacting or dissolving anymore, so that indicates the end of the reaction. Also, I'm out of nitric acid, so I'm going to call it quits. So when it's done bubbling, I'm going to take it out, and then I'm going to evaporate the ether, and I should be left with like a red oil. So here is my evaporation setup. I just have my ethereal oil solution right there, and above it I have a fan attached, and it's attached to a DC power converter, and it's just going to run it and hopefully evaporate it very quickly. As you can see, after it was mostly done evaporating, it started to act up a little bit and seemed to have some sort of runaway nitration happening. Not too sure, but it was very dangerous, and I did not like it very much, so I just let it sit there for a little to cool down. Okay, so it seemed that it stopped being a runaway nitration, so let's test it now. Just to prove there's no ether left, doesn't ignite. From under, though, you can see that it decomposes with a strong flash at the end. That is evidence that we do have our nitroglyoxine. So I ran out of time the day that I made the nitroglyoxine, so this is what it looks like the next day, and it looks like it is all decomposed. So I'm going to have to make some more, but I don't have any more ether, so I have to come up with something. So what I needed to do was throw away the nitrogen dioxide. That's a waste of time. Let's go directly to the source and use nitric acid. Now, what essentially I'm doing is dripping in red fuming nitric acid into a solution of acetone and glyoxine and just forcing it to become the nitroglyoxine that I desire. I also tried direct addition of the nitric acid onto the glyoxine, but this was more for fun and not actually for trying to make the nitroglyoxine. Now I'm just going to try dripping the nitric acid on. Okay, that's enough messing around. Let's move on and actually do the salts. We're only going to be doing the silver and copper salts because the lead salt, which was the third one, just didn't work at all for some reason. So first I try the silver salt of nitroglyoxime, and as you can see when I add it, no reaction occurs. I do the same reaction with copper. I didn't get it on video though, but as you can see again, no solid precipitated, but it is green, and to the right is the yellow silver solution. So for one reason or another, I was way too lazy to clean up my failed reactions, so I just let them sit on my table for 2 days, and after 2 days I was like, okay, I'll clean them up. And I came back and there were solids in there. So I decided to test out the solids, and they just worked. Okay, so after filtering, this is the silver salt, and that's the copper salt that I got from the nitroglyoxime. So hopefully these work. Let's test them. Okay, so let's do the silver salt first. So it's right there. We're just going to heat it from under. It's still wet, but hopefully we get something. Oh, it works. Okay, that was actually really cool. I actually got it to work. Now let's try direct flame. Wow, that's instant. It's still wet. Okay, so I took the rest of what I have and it's right there. Let's heat it again from direct flame. This is the rest of it. Look at that, it left a nice hole. Alright, here's the copper salt. Let's see if this explodes. Nah, just kidding, it didn't work. I also tried direct flame, but obviously it didn't work. However, I did take a toothpick with the copper salt on it, and it did work. Now, you guys may be wondering, well, how do you know you actually had the nitroglyoxine salt? So here I'm going to prove it to you, because like earlier in the video I said that you could tell by the flash. Now, here I have a solution of acetone and glyoxine, and I'm just burning the acetone off. Then I'm going to heat the bottom, and you see that the glyoxine doesn't really burn. What you're seeing burn right now is just the acetone. All that white smoke is the actual glyoxine decomposing, but you see that it's without a flame. Now we're going to do the same acetone mixture, but this time with the supposed nitroglyoxine. As you see, I'm doing the exact same thing. I'm just burning off the acetone, and once it's gone, I'm heating the yellow oil residue, and as you can see, it's actually burning. Seems to be a little more energetic. Thank you guys so much for watching. I hope you guys enjoyed. Sorry about the long wait, but there will probably be another one. I'm very busy with my life right now. However, the videos will keep coming. I actually am working on a huge project right now, and if you guys are really into chemistry, then you guys would probably guess what it is based off this video, because it is based off the glyoxine that I made.